those of you that are not aware, on the SNIA.org website there are and is huge amount of information about the technologies and about the standards development around all of this area. So if this one in particular, as we're talking about solid state today, you'll see everything on here from persistent memory, education, videos, basic terms around some of the technology, some limited roadmaps on the development of some of these standards, and I'm going to give you a more detailed roadmap as it currently stands around NVMe in a minute or two. Customers in general use this stuff and tell us that it's useful for them to get a vendor-independent view of some of the stuff that's going on. Because, you know, as we all know, if vendors will give you their viewpoint on any given subject, which is obviously going to be skewed towards their development and their technology. And we as an organisation strenuously try to avoid that, even though the organisation is obviously made up of exactly the same vendors. But we do work hard to remove the vendor bias, if any, out of any of the presentations that we use. So feel free to use this, there's no cost. If you want to give us some money, we will accept it, of course. This presentation is a chopped and edited version of a presentation done by these two guys, David Allen and Dr. Metz, who you may or may not know, specifically on the evolution.
Mr. Metz.
Sorry?
My nemesis, Mr. Metz.
Oh, is he? Well,
yes, we love to argue about the relevance of the channel.
Well, you can do that with him. It's his presentation, and there was their presentation rather, and I didn't want to go pretending it was anything other than that, to be honest. A couple of things around it. It's an overview of the status of development of NVMe, the management interface, and probably more importantly, NVMe over fabrics, which is the area that the guys from this morning didn't really talk about for obvious reasons, because they're not heavily involved in that. It's not comprehensive, it's not set in stone, and of course there are futures in here. There are development schedules for the standards, which of course are subject to change. So please be aware, just because it's in here and I tell you that that's what we're trying to do, unfortunately that doesn't mean with any certainty that that's what will happen or that it will happen on that date. So it is a futures presentation in some respects. So as I've already sort of alluded to, and as you probably know, there's three sort of separate areas to this as far as we're concerned. There's the base specification, which has been out for some time, and I'll show you the development roadmap in timeline form in a minute or two. There's the management interface, which, as you're probably all well aware, in the storage industry tends to get forgotten until everything's delivered, and then everybody goes, how the hell do we manage all this stuff? So hopefully we've learned from that in the past, and the management interface is being developed as a separate specification alongside the base specification. And then more recently, the addition of the over fabrics part. Now, again, I think for fairly obvious reasons, the over fabrics part initially was all around fibre channel and SANs, because all the vendors involved in SNIA, most of their business today, and probably for the foreseeable future, is in SANs and is with fibre channel. Most of the big organisations, that's what they have installed. Now, whether that will be the case in 5 years, 10 years, 15 years, 20 years, who knows right now. If anything, of course, it will go more and more, I guess, towards GigE and Ethernet connectivity, and the specification, as you'll see, has been expanded recently to cover those areas as well. So when we talk about over fabrics, we are not just talking about SAN, we are not just talking about fibre channel anymore. The whole thing has been greatly expanded in the last 6 to 9 months. Does that make sense?
Yep.
So first came out a few years ago now. I still tend to think of this as a new thing. That is something, NVMe is something brand new, and we've only just started really getting a handle on it. But actually, the original spec was developed about, 2011, you know, 7 years ago now. Sounds a long time to me. So the specifications were first published and then started being released. And of course, there's been iterations since then, and the most recent release of it is 1.3. And that added in all sorts of additional features and functionality. Mobile devices, lower power consumption, other features, which there's a comprehensive list of later. And we'd like to think it's now the only interface that's available across all storage devices. It doesn't really matter anymore how they are connected, whether they're on the PCIe bus, on the end of a piece of fibre channel, over GigE or Ethernet connectivity. All of that is now encompassed to some degree within the NVMe specifications. Adoption in the industry, well, you heard a lot of this from the Micron guys this morning, but it is really taking off big time. Obviously, to start with, basically in servers, PCs, PCIEs, for all the technology that the guys explained this morning, but we think this area of the over fabrics over the next 2-3 years is going to be the area where this specification and use of this technology absolutely explodes. Because as the guy said this morning, I think the number was 50% of all the new storage in the cloud providers is now SSD. And if they're right about the continuing decline in price of that technology, which I'm sure they are, then even more of that technology is going to be used in place of spinning disk. So these specifications become more and more important in our view in order to get the best out of the technology that the customer base is now buying as a default. Certainly up until when I finished at Hitachi, SSD was almost the default. 15K, I think, as they said this morning, was history. 10K for Hitachi had largely gone. They were selling fewer and fewer and fewer 10K drives. So it was really solid state technology in the server device, in the storage boxes for Hitachi, and big slow disks. The bigger, the better, basically seemed to be the customer demand. We don't care how big they are, we want them. And there was really that break, and that was 6-9 months ago. So what they were talking about this morning with the introduction of the enterprise high capacity devices, then you have to believe that will continue to grow. So the implementation and the use of these specifications becomes even more important for the end users. Yep. Encryption's on there. So as I've already said, and they said, and these numbers I checked desperately as they were talking, that these numbers agreed with the numbers they were presenting. I didn't want to shoot them down, but this is probably the most important one. 87% still of all the storage that's shipped is external storage, and the majority of that is going on fibre channels still. Right now. Now, whether that will still be the same in a year or 18 months or 2 years or 3 years,
Surely that number doesn't include iframes.
No, this is for enterprise. This is enterprise infrastructure. So, the big cloud service providers, the big banks, yes, financial. Okay. No, I think if it's obviously an important market, and it's a huge market. But traditionally, it's not somewhere where SNIA has really played that much. It's typically been driven by the big vendors. But if you do go onto SNIA.org and you look at the membership list, you'll see that starting to change. There's names on there that even 2 years ago, I personally would have thought would never have joined SNIA because there was nothing in it for them in those days. Well, I won't mention companies. You can go on the SNIA.org and look at the list of members, and you'll probably be able to pick them out just as I can. It's outside of the Dell EMCs, the Hitachis, the IBMs, the Oracles. Cisco have been a member for a long, long time. Broadcom been a member as Brocade.
Or some of the hyperscalers going in there.
Yeah, they absolutely. Yeah.
So even if not a hardware vendor.
Yeah.
Enterprise doesn't wag. Enterprise is the tail, not the dog.
You're probably
the dog
right.
Is the hyperscalers, the enterprise is just a tail, but it doesn't wag the dog. It just
but I
picks
think
up the pieces that fall.
As Tony said about mainframes this morning, when I got into the industry, I was already told mainframes were dying, and here we are, nearly 40 years later, and they're still going as strong as ever. Not in terms of new customers, and I think the enterprise will be around for a very long time to come.
He exaggerated that. IBM had a breakaway quarter in mainframes, but they didn't sell as many as they did 20 years ago.
Yeah.
Mainframes
Yes.
are
They
as
still
strong
sell
as
more
they ever
MIPS.
were.
Yeah.
The number of MIPS is
That's
still...
They're not
the same
growing.
size
The
Right.
proportion
of the
of the market
industry.
as a whole
Yes.
The
is
rest of the
shrinking,
industry
yes.
is
But
But we
massive.
were told that, I mean, it was just like tape, wasn't it? Tape's dead, mainframes are dead, nobody will ever buy another mainframe. Well, but most of the banks still do.
Well, apart from
really
opening up in
difficult. Most of
China,
the
the mainframe base has not expanded.
No, and it won't, but it will be around for a long time.
Yeah.
Yeah.
I mean, software is the thing that lasts for bloody ever until you emulate it somewhere,
Pension
it will run.
contracts.
Yeah.
Pension engine rule contracts are all on mainframes, and they all have to live for the length of the
100 years.
longest
In the-
person.
No, it's
The
in
person who
perpetuity.
has the
In the UK, it says in perpetuity. It doesn't say for the life of the universe. How the hell you manage that, I don't know. But
Yeah.
you've got to keep it around for the life of the universe.
But as IBM killed off all emulation,
That was rather
Whatever Lawmaker wrote that one.
IBM killed off all emulation of the mainframe. So
Yeah, they
there's
did,
slow
yeah,
migration
absolutely. They wiped out the PCMs, Hitachi and Armdale. I think Armdale got a mention this morning.
Yeah. That's about it.
Yeah, but they also
Well,
there
they
was
killed
a
the Hitachi
x86 mainframe emulator.
were doing
they
the same
bought it
business.
and
The
shelved
reason
it.
Amdale was mentioned is that
Chris worked for them,
So
yeah.
did I.
Yeah. Yeah, but when I joined Hitachi, that's exactly what we were doing. Quite compatible mainframes, and they squeezed us right out of the market on just by purely on money and by loading the software costs. By the by, ancient history. So, as I've already said, the fabric side of this is where we see the future, and encompassing all the other connectivity that storage devices have outside of fibre channel and traditional SANs. So what's next? So I've got a couple of versions of this, but I think the most important thing is to show you, one, there is a roadmap, and that there is a growth in this area of what we're trying to achieve over the next 3 years. The next one's more detailed. I just wanted to put the milestones in this one. But 1.4 you can see is already scheduled for next year. 1.3, as I said, has already been released, and hopefully will go into implementation in the not too distant future. That's on the base side, the fabric side, and as I've said, the management side. Now, in the presentation I will send out, definitions of all of these will be given, but I didn't really want to stand here and read to you what they are when you probably can guess anyway, and if you don't know, you can look at the words on the documents that we'll send to you anyway, rather than me read it to you. So we think it is strong. There's over, incidentally, in the specification side, the specification generating side of this, there are now over 150 companies involved. Now, I doubt if any of us can name 150 SSD suppliers, but that shows you the diversity of the organisations that are actually involved in generating these standards. If you look through all the SNIA special interest groups, this one has about twice as many members as any of the others.
Yeah, makes sense.
Because that's obviously where they think the money is. Well, there's a little more detail on this one. Again, you're more than welcome to have copies of these, but as I've already said, they're not set in stone, they are subject to change. So just be aware of that. So on the TCP transport side, fairly self-explanatory slide, I think, in terms of the host software, the interface, and the subsystems, however they're connected. Fabric side, again, as I've said many times, including Ethernet and fibre channel from the T11 committee, which is working in conjunction with this development, and over the transport side. So basically, it enables NVMe to work over all fabrics. That's the end goal.
Which of these, in your opinion, the three areas, is the one likely to have the most change from the current idea of what the roadmap looks like?
That's a good question. Ooh. I would think it's probably this area.
I would have thought that one, given that it's, the real junior in the pack end.
It's the most recent addition. It's the most, what should we say, underdeveloped is probably a fair way of describing it. And until recently, it's probably the area that SNIA as an organisation had the least amount of experience in. Because when you look at, as we've already said, the traditional manufacturers that were involved in SNIA and have been for 20, 30 years now are the high-end traditional enterprise storage companies. And most of those, maybe one or two exceptions, didn't do a hell of a lot in the Ethernet space. In fact, quite a few of them still don't have any storage that will attach in that space. They are still SAN fibre channel only devices, which again, I think it presents an interesting question for the future of what those companies are likely to do. Because if as we heard earlier, they are correct that maybe the SAN fibre channel side will slow in growth or stop in growth, and it will be the Ethernet side that now leads the charge, if you like, into the next segment of growth in the storage industry. Some of those companies could be in big trouble because they won't have the experience, they won't have the knowledge, and they won't have the people in order to be able to participate in that side. Having said that, the mere fact that they're involved in these committees says to me they do understand that they have something missing currently.
How far is this aligning with growth in hyperconverged?
That's a good question. I honestly don't know the answer to that.
From what we can tell from our research, it's not yet. So hyperconverged is going ahead without NVMe over Fabric. There's only a couple of instances where they're trying it with things like Mellanox, but it's trials only, not really production.
Hyperconverged today is too small to need NVMe. They can get by just fine on SATA. They can use cheap and then overprice them and make loads of money for no effort at all. So they'll wait, basically.
Yeah. They're not
To me,
using
it's
this
very
Fabrics
EMC,
concept
right?
yet.
Remember, EMC always chose obsolete technology to sell because they make profit out
But
of it.
Mellanox do a great demonstration where basically the architectural enhancements of the RDMA basically bypass the entire OS storage stack. So doing a
As long as
doing
you
a
have
request.
the expertise to actually get Mellanox kit working.
Yes,
Yeah, but
absolutely.
that's the whole point at the moment. It's still so
It's not mature
it's still
enough.
so immature that it's something that
But doing a remote request is often quicker than doing a request through CPU back to local storage. So
That's a common fallacy. RDMA over Fabrics is trivial. It's far easier than fibre channel.
So,
Because I'm doing that in petabyte scale today.
But are you doing it with Mellanox?
Yes. Mellanox NICs, Mellanox switches.
You are the only person I've ever met who said they're not difficult to set up,
Yeah, it's fine.
and
Trivial.
including people I know at hyperscale cloud providers.
It's trivial.
so
It really is. And we're seeing things like VMware's vSAN, and there's a couple of other of the distributed storage providers switching into RDMA to get acceleration. But they're doing it as part of their blessed, hardware-defined storage model. You can only buy this storage, and that means the hardware makers sell that storage product. So there's actually a viable, rip the customer off business model there, because if you say your software can only run on my expensive hardware because you need RDMA support, then that actually is a money spinner for the big companies. The thing holding it back is RDMA doesn't make money for most companies.
right. So here's another question. This has come up a couple of times, and I don't really have a thought one way or the other, but do you think the failure of FCOE with enterprise storage is going to hold any of this back, or do you think people just go, it didn't work, move on?
it's going to be a footnote in history long term, I think.
FCOE was solving a problem that didn't exist. There's no point in putting a fibre channel over Ethernet. It existed solely so that Cisco could justify why its UCS service should cost 70% more than anyone else's service. And back in the days when, as soon as FCOE came out, fibre channel pricing equalised with Ethernet. Because there was you couldn't pretend that fibre channel had magic superpowers if you could just run fibre channel. So all of a sudden, this forced fibre channel to price at Ethernet prices. And then the fibre channel manufacturers came cheaper than Ethernet because they were worried about losing the market. And then, so now you've got this sort of fibre channel and Ethernet come around about the same price today, right? Because anytime fibre channel tries to lift its price above the equivalent Ethernet rate, the market just shifts to Ethernet, right? So
not
now
enough
the
people
fibre
tried
channel
it, so it doesn't matter. It's not going to be.
That was my opinion, but for what it was, that we shipped
really
like
got burned by it, so.
one array, I think,
But
with
they also
FCOE
wanted to
on
sell
it.
the big replacement switches.
And we're not even sure that got
catalysts.
used.
But I think you also saw the rise of NFS and
They
ISO.
weren't burnt by.
Sorry, you saw.
Also saw the rise of NFS
Yeah.
block storage over Ethernet.
There is
Sure.
no,
So Once you've accepted that you're going
try
over
this once,
Ethernet, why
I'm
run
trying
fibre
to
channel?
get
Why
it to
doesn't
be
switch to
solid.
benefit?
You switch
So
it.
therefore, I
Yeah.
don't think
And
there's
so
inhibiting.
So
It's not-
FCLE was never going to win.
Yeah.
Because it
It's
put-
just, can I trust it?
and from Cisco's point of view, what it did
Which
is
is a
it
different matter.
gave them a chance to enhance the value, uprate their products by saying they were fibre channel FCLE ready. It basically allowed them to charge twice as much for the same switch, right? Because you needed all these extra features to fibre channelise it. So it didn't make any sense it was never going to make sense from the start.
Right.
They still use it today though in their UCS servers if you're
Yeah. I understand from Cisco
Cisco's
people
the
that
only
it's
company.
quite popular within that in rack, if you like. But it's, being from a storage vendor originally, we just never saw it. I mean,
The
it got
idea-
talked about, but it never happened.
Yeah, the idea that, so basically what Cisco is doing is saying, instead of having a fibre channel NIC and an Ethernet NIC, we'll share the fibre channel NIC over the, but what they did was replace the NIC with a switch, with a $50,000 switch. So nobody won, right? So it's not exactly a viable. No.
No.
NVMe, on the other hand, gives us a way out of SCSI. We all know that SCSI is dead. And
Yeah.
it's got all these command verbs that are all predicated on technology from the 1970s. And if you want to clock past the limitations of SATA, you have to get rid of SCSI.
Well, I think that was the point the guys were making this morning, wasn't it? That if with their testing, as I understood it, they've rewritten part of the stack and they can get a significant, on their numbers, a significant improvement in performance by just changing the software stack that's driving these devices.
It's the difference between COBOL and Go, right?
Yeah.
COBOL is fine, but it's verbose, it's hard to
Yeah.
compile, it's hard to optimize, it's hard to do well.
Because everything we've used has always been disk
Things
is the
that we
slowest
invented
part,
in the 1970s.
and the disk takes an hour to do anything, so it doesn't matter how much protocol overhead there is, because it will still be finished long before the disk's ready to do anything.
That's right.
And now it's changed completely. With the disk equivalent, if you like, is now sat there waiting for everything else to catch up.
Yes, that's the story that Intel told us.
Yeah.
Told me anyway, that SCSI commands are too slow.
Yeah.
And they're not. You can't accelerate them.
And we've seen that with customers where, it's going back a couple of years now, but where they started doing massive server consolidation, they started reducing the number of SAN ports into the SAN. So, 16 physical servers with 4 paths each down to 2 with only 8. And suddenly it was the bottleneck suddenly was in the connectivity and not in the SSD devices that were on the end and not in the server stack. So I think one of the guys this morning said, we always move the performance bottleneck. It's always going to be somewhere, but for years it was on the disk.
Yeah.
Then suddenly it switched to in the middle. Now it's the protocol. They keep up ramping
If you talk to
the
Facebook,
speed.
they're now so in their storage servers, they're now running 50 gig Ethernets
Okay.
and ready to move to 100 gig.
Yeah.
So because what they're doing is when you put 40 or 50 SSDs in a rack, you need that much.
You've
speed.
saturated
And if
the
you saturate-
the ability of the protocol over the interface to be able to keep up with the speed it can shift the
Even
data.
at SATA,
Yeah.
right, with 6 megabits per second, you've got 40 of them, you can saturate a 50 gig link.
Yeah.
And so what they're doing now is when you go to NVMe, you'll reduce the latency. So you
Yeah.
actually increase the bandwidth that can be consumed and burned.
Yeah.
And then there's a second phase where they're moving to 100 gig now.
100 gig, yeah.
As by default. So
Yeah.
So this seems to imply also that this is really technology that works best with hyper-converged.
Maybe in the longer term.
no, no. In fact, NVMe is actually best suited to smartphones because it dramatically reduces power burn. So instead of issuing SCSI commands that have no, so today we're still issuing pseudo SCSI commands over the SATA interface in phones, right? And still fetching blocks effectively in some of the operating systems that they have. And you think about how much power that burns.
Yeah.
Right. Whereas NVMe discards all of that and basically has a get and a put and a
Yeah.
read and a verify, and that's pretty much it. Right?
Yeah.
And so your power consumption. So hyperscalers are hungry for power, so they're chasing down this technology and driving it.
Yeah.
And the enterprise will come along in the backdraft, like
Yeah.
they'll follow along that because once NVMe's been paved out by the big hyperscalers, we'll
Yeah, I mean, there's it's quite interesting actually. If you go look at an early hyperscale data center, which has been retrofitted with modern hardware, how empty it is because the power density of modern racks compared to the racks that were there initially. So they now have a lot of space in those buildings and not enough, and they can't get any more power.
We have the same problem now.
They're
So if they
fine on
can-
the cooling, they just can't get enough power to run
Yeah.
anymore.
That's right.
It depends on the
We've seen it in data centres all over Europe.
You know,
Yeah.
with more power,
Where there's quite a lot of colos that can
adding
do
extra
2.5
functionality
kilowatts
without
per
putting
rack.
more power.
Some can do
It's
5.
going to be an economic win for them.
And
Absolutely.
very few
And
can do
there's
10.
again, going back to what the
Any
guys this
sort of
morning were
level
saying
service
about the
would
increase
be
in
very
density of the chips they're producing and
So
the fact
most
the
racks are
the
like
wafers
5,
they produce,
which is a bit low.
they're doubling the density for no more power
They've
consumption.
actually
Yeah.
done much
But I mean, we're
better.
coming to the end of
Room is
Moore's law,
empty.
so if you're looking at
And they've got
computational, we're
plastic
struggling to
sheets
get
that
down
you
to the
get
lower
in
process
industrial freezers
sizes.
to
If
do
we do move
offload
down,
Yeah,
we
that's
only have a
it.
size advantage,
And
not
That's
a
why
power
it's
advantage.
empty rooms.
So we're getting to a
You know,
stage where we actually need
The
better
last project I did
architectures
with the VMAX
overall the
was
entire
actually
system.
to-
And
Because
really,
it's
and the
optimization.
architecture,
Cost of
people
getting
tend to think when you talk about
full
architecture, hardware,
wasn't
actually
working.
it's the software architecture that
Yeah.
drives a lot of these systems, is the bit that hasn't been changed for the longest.
I used to be at Intel along with Justin Ratman about making the
No, no, no,
CPU
no,
and the
the
systems
weight.
efficient.
Yes,
What
but
the
wasn't
VMAX
becoming
puts
efficient
all the
was the
weight in a
algorithms.
single
Because
chassis.
programmers
Yeah, don't do a
very
race
rarely
floor at
focus
all.
on performance
Nothing to do with the race floor.
or
It's
efficiency
just
because
the
it's
wall
speed to
alone
market,
cannot bear
it's
the weight of the
functionality, that's what they
VMAX.
focus on.
Yeah.
Because the
So unless you do what
rated
Apple does every
X
few
number of
years and
tons per square foot.
park feature
And
development
the
and go
VMAX
and
puts
bug
it all
fix
to,
and
like 10
do
square
Why
stuff.
foot.
the
We had to throw the VMAX
underlying
away. We couldn't
shift
buy it because it wouldn't fit in the data center.
highly distributed applicative development on containers
Yeah,
and through
because
servers
Which is this is
Yeah.
this is
actually
one thing that
is going to have very interesting side effects on the overall efficiency of the modern data center.
We should probably try and get
One conversation, yeah, sorry.
Because customers were turning away from VMAX because of that.
Should we,
Yeah, we've gotten to VNAX now, so we'll come back to this.
Power rate efficiency ratio.
Sorry?
Power to weight efficiency
Yeah,
ratio
yeah,
of a data center.
we went
when
through all
the floor
that.
can't physically
Yeah,
support anything more.
That's when I walk down it.
Yeah. But you're right, going back to what you were saying about data centres, the number of customers we were seeing that, 10 years ago had built a new data centre and now everything they need is stuck in one corner and 3/4 of it is just empty. And they're desperately trying to turn it back into office space.
Yeah, well, they're wanting to shift the workload into the cloud these days as well.
There's that as well, but also the miniaturization, if you like, of everything and the consolidation of all the hardware has just outstripped anybody's imagination from 10 years ago of what's been achieved from a hardware point of view.
Yeah.
So again, future developments specifically of the over fabric side. Again, copies of this, you can see what we're trying to achieve there, and you've already seen the roadmap for 19. The end-to-end use, simplicity, efficiency and low latency by rewriting this stack, including RDMA, base transport, SAN fibre channel and everything else as we've already mentioned. And I don't think there's any hard and fast rules around this. The committees that are doing this are open to new suggestions all of the time about what should be included next in this. For instance, what do we take for granted on what we've already got in terms of the ability to manage all of this storage that we don't have in this? Because we're not for 1 minute pretending we've got everything now down, because we haven't. And there's, again, from what the guys were saying this morning, the developments of this are going even faster than they expected them to. But the Micron guys actually are involved on the committees, so their development guys are involved. So I'm pretty confident that we'll have most things done by then anyway. So the host software side, the TCP IP stack, so all that's being considered as well. So again, as they were saying this morning, performance is key for all of this, helping customers get the maximum performance out of the hardware technology that they've spent millions investing in over the previous 3 or 4 years, and hopefully will continue to invest in. So that was 1.1. This is 1.4, so this is for projected completion next year. So this is all the future stuff. So the I/O determination side, i.e. trying to be able to do what we can already do with a lot of this technology. So being able to partition these workloads, being able to make sure that the workload is only looking at the storage it needs to rather than the whole block. So again, trying to improve the throughput capabilities, the performance capabilities of this this technology as well. And obviously help with the QoS side. On the persistent memory side, again, they were talking about this this morning. So having persistent memory support within the specifications as well in 1.4, which as I said is due in 2019 as it currently stands. And again, multipathing and namespace sharing, so the ability to be able to use this with things like object stores, which use a lot of the namespace sharing type technologies at the lower level. So all these things are slated for availability on this specification on the 1.4 release, which, as I said, is due in 2019. And the relating capabilities around multipathing as well. So the host port side, the controllers and the namespace, proxy servers and controllers are all built into this, again, for the future. So that's pretty much everything I was going to cover. It's gone through a bit quicker than I thought, but so there's 50 projects currently going on this with, I said 150, it's 130 participating companies to develop these specs and get them to market and tested as quickly as possible. As I've already said, there's a huge number of resources available on the SNIA sites and other sites around this, around the development of this. So if you do want to follow what's actually going on in terms of the development of this standard, the rollout and delivery of it, they're the places to look. And questions, Twitter, all the normal links for the various working groups. So I know it's a very quick overview on this, but I thought as I was last today, you probably wouldn't want to listen to me for too long. But what I'll do is I'll email Rachel the 2 separate presentations around this. So the base one with all the definitions in, and then the futures one, which goes into detail on every feature and function. So hopefully you'll get those today. Are they going out today? Okay, we'll do that in the next 5 minutes. So any other questions around this or anything else SNIA's doing?
Could you just go back to the symmetric slide a moment?
Symmetrics? No, we don't do symmetrics.
Asymmetric.
That is old. Did you read the multipathing?
Yeah, it said symmetric multipathing.
Yeah.
As opposed to EMC symmetrics.
Yeah, I thought you were talking about EMC symmetrics. So even EMC don't sell those anymore, or Dell.
Unless there's an old one in the warehouse.
I'm sure there's still a lot installed, but
This is important because when you start running fabrics over Ethernet, you don't actually have, so most people deploy fiber channel networks as 2 networks, and you have 2 paths in between
2 paths,
networks, right? Which is expensive because you've actually just built 2 networks and you're only using half of them, right? That's a bit stupid, but that's storage. In Ethernet networks, we build fat trees, or we build cloth networks. Like if you're doing it in a modern fashion, that's where you actually have, like in the network, one of the networks I work on, they have 16 switches in a spine, and then they have 36 switches in the second layer. And they actually have a total throughput of 480, 12 times 40, so 480 gigabits per switch. So one-to-one non-blocking, 48 10 gig ports, 480 gig to the spine, and it load balances across all. So that's a 480 gigabit basic network. That's 5 years old, that's obsolete. We're replacing that with a, I think it's like 1.2 terabits per second from the switch. So we'll be able to do 12 100 gig south, 12 100 gig north, and load balance equal across them. So this is where the multipath comes in. You want to be able to load balance the flows across multiple paths from the point destination to destination.
Yeah, so what I was wondering about was with software-defined networking management and troubleshooting, where you're looking at the presentation of the paths within the network and whether they really are the same, because one router will sometimes learn the wrong weightings for the paths, because not all the routers, if you don't have the same firmware from the same vendor on every router, sometimes you'll get paths reporting back as, I'm absolutely faster on this.
That's not how it works in the data center. That's correct for the wide area network, where you have multiple paths with different characteristics at different speeds. So you might have a branch office that has a 10 meg connection here and a 2 meg connection here, right? And so you've got different, and one might go via one technology and one might go another. So the path, this might be a fast path speed-wise, but a slow path for data. This one might be faster from a speed perspective, from a latency perspective, but slower by speed. Does that make sense? So
it's
that's different. So what we do in the WAN for pathing.
Something that some of the hyperscale cloud providers are looking at in terms of their internal network management, which is both within the data center and wide area network between them.
It's not a problem with storage. We put the storage into an ECMP network design where all paths are equivalent and load, and then we get what we call packet spray or flow spray across all available paths because they're all equal. We specifically design the network just like a fiber channel network is designed so that all paths look identical, and the routing protocols weight them equally, so that load spray is fair and even. You wouldn't build a network that's not that way. In the same way you wouldn't do it with fibre channel. You wouldn't build a fibre channel network.
It would cause too much trouble, wouldn't it? The problems would be an
And
absolute
storage
nightmare.
networks are trivial because they're tiny. They're usually only a few hundred ports or a few thousand ports. They're not a big deal usually. So you don't have those sorts of pain thresholds that you have. But what you say is true for 20 years ago in networking, but not for modern networking.
If storage access is slow, then that is painful. I mean, because that affects everything that's being used. So it gets flagged up pretty quick. If suddenly online customers can't access their bank accounts.
The most common mistake is that people are still implementing like network designs from a decade ago. So they're doing tree or distribution access, and they're very late.
Have you looked at the CrystalNet paper that the Microsoft Azure network monitoring team put out last year? One of the things that they're looking at a lot is whether the paths through their network that are reported as being equally performant actually are equally performant. They found that in a high percentage of cases they weren't, because of the mix of firmware and vendors in the network, and some of the network paths that got presented, router aggregation of paths and so on. Lots of things.
That's a problem unique to Azure, because they're the ones who haven't done a very good job, as they now know. They've realised that they're not doing a very good job with their network, and they've now spent a lot more resources going forward. So when you're designing a distributed storage network, there are certain things that you should do. And the first one is, like, don't deploy at less than 10 gigs, and preferably be at 25 gigs and above. So everything should be 25 gig or better. Don't do it at 10, and definitely don't do 40. Right? Even though the incumbent vendors are trying to sell out their 40 gig stock, get away from it, because the 40 gig is much slower than 25 gig, weirdly, because of the latency and the encoding. You've also got to build ECMP clost fabrics, so proper fabrics, not legacy network designs. But a lot of people are taking their Ethernet storage and just plugging into the network and going, that works, and then finding out that under load it's not working.
It can't support it.
Yeah, that's not the right. You need to understand, and unfortunately the average level of training and competency in an enterprise is pretty low, right? Especially around networking, because most of the time your average enterprise network engineer doesn't work in the data center. Once every decade that network gets looked at. They spend the vast majority of their time in the campus, in the Wi-Fi, or in the DMZ where the firewalls are, and the data center LAN is kind of like, 5% of their life. And so it doesn't get a lot of focus. It gets set up, locked down, and then left alone. And they don't spend a lot of time working through issues.
Well, that will change once, or if they start depending on all the storage connectivity across it, because they will just run into so many problems.
Well, it just takes time for these best practices to flow down. And this is where SNIA could potentially help.
And I think they will.
Yeah.
I don't think there's any doubt about that, but it's got to get to the deployment phase, and it's got to get to the point where we can actually get these in and test them, and then find out where the glitches are and where the blind spots are.
Network engineers don't know what they don't know. And the storage people also don't know.
No.
Right? They have no networking expertise. They're used to plugging things into fibre channel and going, that worked, and never touching it again. Because the storage arrays were so slow, you never had a networking problem, right?
Well, that's not true. I mean,
generally, not just in storage and network.
You look at most storage guys; they spend most of their time looking at performance problems.
Yeah.
You go to any,
but not in the network.
no, in the connectivity from the storage array back to the server. I mean, you look at nearly. I bet if you go to every support organisation from every one of the large vendors and find out what most of their technical support guys spend 60, 70, 80% of their time on, its performance problems, and they're not in the array.
Yeah.
Well,
The array gets blamed. I think, as somebody said earlier, the first thing is it's going slow. It's the array.
This
9 times out of 10, it's
a
not.
problem in organisations of all sizes, because performance monitoring has been very, very siloed, based on individual elements, and trying to piece together the entire picture is bloody hard.
Yeah, it's always been really difficult.
Put in place a proper performance monitoring infrastructure. So VI does some of that on the storage side, and there are other tools that do it, beyond the server out to everybody else. But if you actually put in a good performance monitoring infrastructure, then you can actually use that to do a lot of elementary root cause analysis, like where the hell is the problem in the first place, instead of having everybody.
And it could well be
because
that's going to become more and more important as this gets deployed.
We didn't need performance monitoring because networking, but increasingly as the complexity of the data center changes,
absolutely,
we're seeing the rise of what they call intent-based networking. And a key part of intent-based networking isn't just the configuration aspect, it's the monitoring and visibility tooling.
And
So
the way that
there-
things need to change.
Yeah.
So
it's going to be difficult.
There's going to be a whole reskilling of the traditional storage environment.
It's
Well, the challenge is what's driving, this is what's driving the cloud. It's a lot easier to not
Yeah,
reskill. to
just dump and move it.
And what you're doing
Not
is
dump
kicking
it,
the
move
pain
it.
down the road.
Christian and
Because
I,
you're moving into
when
the
we went
cloud.
round after
And increasingly what we're seeing is people
spent
go to the cloud and
3
it's like,
years promoting
I call it cloud tourism. They go, oh look, the cloud, oh it's so beautiful. Oh,
essentially as a
it's nice to visit, but I wouldn't want to live there.
I did a
Right?
degree in-
And increasingly they're saying, like, there are some things that work, obviously, if you just want to drop storage,
Yeah,
but
we
as
did
the
this
bill
back in
continues to rise, you start to think, oh, is this wise? You know,
everybody
and then they start
we
putting
talked
like a
to
data
was
management
using
solution on
Yeah.
it, you know,
built
and then they go,
originally
oh, actually, this is.
And we've been here before in other ways. If you go look back with EDS from a long time ago, people moving large scale, everything they were doing to EDS. 2 years later, that bill's got really painful. We'll move it back in house again and look after it ourselves because it's
So there
cheaper
is
and better.
I do think
Yeah.
there is an aspect of SNIA which should be saying to people, you know, if you're going to build a network that has distributed storage solutions on it, you should think, you know, you should be looking at CLOS, you know, ECMP CLOS fabrics of some sort with a visibility tool to show you what
Okay.
performance is, and that should be like a general. And at least then, you know, the storage people could go to the network and say, look, here's some ideas,
Right.
and start to
That's
prompt
fair.
that discussion.
Okay.
And then there should be another white paper written by a networking person with
Looking
in
at it from the
concept,
other
you know,
side.
you know,
Yeah.
get me and Jay Metz in a room and we'll argue about what that kit looks like. But you know, like you know, written from the networking point of view, one from the storage point of view, so the storage person can read it and go, oh, I see what the networking needs to do. Another one written from the networking person's point of view, saying this is what storage is trying to achieve. Here's how you solve it.
And then the two of
Yeah.
them need to get together to actually write something that they can use as a business case for getting the
Yeah.
software.
So then
in
the
first
idea
place.
is that the networking guy then sits down with the CIO or the CTO or the thing and says, well, we have to read, you know, this is the reason why we should be investing in the network if you move to distributed storage. Because most of them now go, I don't know, just plug it in and see if
See
it
if
works.
it works. Yeah.
Takes me back to
Because
when-
why would I? That's all I've ever done. I've only ever just plugged in servers and done my thing. Does that make sense?
Takes me
Yeah,
back to
absolutely,
when
yeah.
I was working in data centers when networking really became more than point to point. Just very early days, and people started doing really stupid things
Well, the
like,
big transition
like
is-
firing backups over the live network. that
Well, we used to have we had the 80-20 rule. 80% of the data left the data center, so it was all out.
Yeah.
That's what happened. There was no east-west
Not
was
now.
less than 20%
Yeah.
of not having. And now we've seen the transition with
It's
the
really
rise of
shifted.
distributed storage
Yeah.
and you know all the virtualization and all that sort of stuff. And now we're seeing 20-80. Only
Yeah.
20% of the data leaves the
And the rest is just shuffling and
And the
moving
rest
from
is
side
actually,
to-
you know,
yeah.
distributed storage,
Yeah.
synchronizing, vMotions, DRSing, you know, whatever it is. But that requires a new network design. But most people aren't being taught that or getting insights into
It's
that. They
still
don't
top
understand
down.
that the transition has happened, that forces a change.
Yeah.
Vendors aren't doing a very good job of it either, it must be said.
They probably haven't noticed they also switched to VoIP for most of their calls and putting half of those over the same Ethernet.
The networking engineers certainly know about that because in the old days when there wasn't a lot of bandwidth, we actually had to engineer very heavily to make that possible. Today, it's not an issue because we actually have, you know, when we're doing gigabit to the desktop, the idea of 90 kilobits per second for a voice call is kind of trivial.
Yeah.
You know, but so now we don't need to worry about it because bandwidth solves all problems. Yeah. So you know, if you're having a problem with your storage array at 10 gigabits per second, just upgrade it to 25, and the problem will go away.
Go
And if
away,
that's
yeah.
not enough, then go to 50.
Well, that's
That's
what
the
they were doing.
Microsoft
That's what they were
answer.
doing with fibre channels.
To everything.
It is.
Just
It is
chuck
the
more
cheap-
resources at
Your
it.
VoIP call has video now.
No big deal. It's still even a full HD TV 4K is still only 7 megabits per second. So no, not a problem.
Okay. Anything else on anything else, basically?
I've got a couple of things.
Let's
Have
go
you?
on to take
Oh dear. Start talking
couple of
about
the
tape.
other topics that were flying around, but I'm going to talk about it. The board felt that of interest, and this is for you guys around the table to tell us whether you'd like both to share some thoughts, would be object storage, and the other one would be the evolution of higher speeds for storage traffic, the situation with 32 gig and future 64 gig fiber channel. Would you like? Do you have any questions on?
Or a point of
either?
view even around some of this stuff. What,
I'm not sure that higher speed is the correct definition because the speed is still controlled by physics. So,
But again, it's more channels, isn't it? So it's
Paralysing,
paralysing, yeah.
which isn't higher speed.
No, it'll get you more throughput if you're lucky, yeah. But there's a law of diminishing returns even with that, isn't there?
What about object storage, guys? Lots being talked about. Obviously, we represent an object storage vendor, but I don't know, there seems to be like very few companies, and a couple were acquired. Some people were saying it's not right, it's not ready yet. Any thoughts around the table about object storage? What do you think? Good, bad, not ready?
When we survey people, they tell us that they like the idea, but they've got no idea what the practicality is, or the maturity, or how easy it is to implement, what they need to understand about things like erasure coding, etc. So there's basically still a huge education job to be done.
Yeah.
There's also actually, I also think there's a level of confusion between object storage and document databases, which themselves or blob stores, which are also seen as object stores.
Yeah.
And so
It's a language.
whether it's hardware or software is an issue. Certainly, talking recently to a relatively new entrant, they call themselves an object storage vendor, but really they're a file storage vendor with very fast indexing. And that's interesting, but
Yeah, it's an area that has generated a lot of noise, so there's a lot of confusion. Understanding generally about where it's useful to use isn't that widespread. Practical experience of it outside of the very large cloud providers is not that extensive. It tends to still be mostly targeted at archiving or long-term, relatively cold document stores. People just do not know enough. They don't even know whether it's mature enough to be used in anger. So that's part of the issue.
I think because it evolved from a lot of companies from the archiving space. It's a lot of people still think object store is just another name for an archive.
Yeah, and it's mixed in with the whole problem of confusion and lack of knowledge. So you've got a huge education job.
So we can probably do a better job around that, or at least start doing some
What are
things
the
around
use
that.
cases of how it works and where it benefits
Where it fits.
over traditional architectures?
That's exactly what you've got to get out there, because that's all people care about. Is, where does it make sense to use this? How do I use it? How do I get it from here?
Yeah, why is it difficult for other technologies to do what this can do?
What do I need to understand about erasure coding? I probably know enough about RAID to be dangerous, but erasure coding's different. How is it different? How does it affect the way I need to operate and manage this stuff?
Having said that, I think
objects and object tracking and all of that. So the multiple versions, the reduction of need for backups doesn't eliminate backups, but maybe reduces the need for the traditional backup.
But on the erasure coding point, customers are using it and they don't even know they're using it.
I know, but that doesn't necessarily mean it's a good thing.
But I think some of that technology to some customers is irrelevant.
To some, yes.
If you can platformize it and therefore remove the need for the application developers to think about it, they can just program to a set of APIs.
Right.
So things like containerization and others are probably going to drive object storage longer term. They're probably going to actually develop hand in hand over time.
Yeah. Okay, I can take all that back. Thank you.
You can speed up adoption by helping people be more comfortable with it. And that's essentially education.
And use cases.
I would argue that use cases are part of education.
Okay.
A very important part of it.
A specific part of it, but one that's very defined around actually getting people to understand where it's relevant. Because otherwise you're going in and you're basically trying to say, well, there's a dam and there's a few other things, and it's all water, what's the best thing?
How do I put it together and what do I use it for? Okay. Thank you.
Good, well, thank you.
Anything else, guys? Any other questions about other storage technologies or about SNIA in Europe in particular? Bob, do you want to maybe briefly talk about what we do from a technical point of view in the US, what SNIA does, what it is involved in?
Well, the list is huge.
Because
I mean, everything from...
in Europe, we are not involved in the technical side of things. We're purely a marketing and educational organisation. In the US, we've got the technical communities.
I mean, all the areas that SNIA are involved in, so everything from backup, restore to archiving to object stores to the SSI to cloud to anything you care to name that's relevant, I guess, to the enterprise storage market and increasingly to the non-enterprise. SNIA will have a technical working group on or a special interest group on, and there will be a number of members in each of those groups, either providing education material, running conferences, speaking at conferences, and or developing standards around that technology. It's interesting the way it's grown in the States, because I think for those of us that have known SNIA for a while, 4 or 5 years ago, the future of SNIA, even in the US, looked a bit on the dodgy side, to be honest. There was a bit of a lack of direction. Nobody really knew what the organisation was going to do in the future. And over the last couple of years, that's completely changed. The membership has increased and increased dramatically, as I said earlier, from organisations joining who 5 years ago we would never even, well, one, they didn't exist, and two, we would never have thought they would have joined even if they had have existed. So that has really been driving a lot of the expansion of what SNIA has done and is continuing to do.
Well,
it's not the Dell EMCs, the Hitachis, the IBMs, the Oracles anymore.
Would it be fair to say that SNIA exists because it helps to manage change? So it helps to get vendors in a place which allows them to duke it out in a fair and reasonable way that doesn't...
Yes.
It comes from the problem that in the beginning, storage
it was the complete lack of compatibility, and really
inhibited sales, it inhibited everything.
and you know, the first implementations of Fibre Channel clearly showed that total lack of interoperability. You know, all the vendors in the early days of SAN had to invest millions of dollars setting up their own interoperability labs so it worked. They knew it worked with this HBA, with this switch, with that piece of storage, but that's all it worked with. And it had to be this way, firmware level, and every point was defined.
Technology that actually didn't need that. But, I mean, seriously.
It's where it came from.
It shouldn't have, but it did.
It should, yeah.
And
I just pointed out the fallacy.
Yeah.
So I think what you're seeing is that NVMe is a major transition, and the vendors know they need to work together to work through it again.
Well,
Standards bodies need change to drive interest in them, because otherwise and nothing happened in storage.
Yeah.
And so it wasn't relevant.
And it got very samey. When you looked at what was going on with the storage vendors, year after year, they just announced a bigger and better box that didn't actually do anything else. It was just bigger and faster.
Yes.
And that was pretty much the limit. You got a couple of bells and whistles.
But SNIA got everything so that it was better able to work together.
Absolutely.
And once that issue had not quite gone away, but had become much more manageable, then that's when the lull set in, because what was there next to do?
Yeah. No,
whereas now that's changed again hugely. And I think the other side that drives it actually is customers drive it, because the customers that were involved in those early days of Fibre Channel go, we're not going through that again. We're not spending huge amounts of money to purchase a load of stuff that quite frankly didn't work. Yeah. You mentioned that earlier.
It was time not to work really, from what I looked at.
Well, yeah, maybe. And now I think you'll find customers are much more switched on when it comes to compatibility of everything.
Yes. That
I just expect to be able to plug all this stuff in and it should work. Yes. And if it doesn't, you better have a damn good reason why it doesn't, and you better be able to fix it. Yeah. So yeah, getting in these standards, the NVMe one is a good example. All the vendors that want to use it, they want to get their bit in, obviously, make sure that what they want to do is supported within the standard, but they want to make sure everybody's conforming to that standard, so the interoperability problems are not there from day one.
Yeah. The biggest change of all has actually been the fact that the standards are actually being standardised much more quickly than before. It used to take,
it took forever.
All the standards were 14 years behind where the vendors were because of basically their own reasons, but it's got much better at that. It's still not as fast as it should be, but that's the nature of the beast when you've got a camel committee.
But you saw that with the early releases of what was the SNIA, which was the first sort of stab at trying to commonalise management interfaces. The standard came out, but the horse had left years ago. And you were trying to standardise things that customers had got used to the uniqueness of.
That in particular defined was of such a low functionality level but it was next to useless anyway.
Because that was a problem of getting all the vendors to agree to something.
And they didn't recognise at the time that that very lack of interoperability slowed down their own damn sales opportunities because people are afraid of making the wrong decision.
And that again has probably benefited us now, and now it's benefiting us now with more people getting involved in the standards and the definition of the standards, the writing of the standards, and getting the move to ISO, as you say, is now much quicker than it has ever been before.
Could still do with a bit of a speed
Yeah,
bump.
of course.
But
you know, one of the other problems here is that nearly everybody that's involved is a volunteer. Nearly everybody that's involved has their day job. You know, whether they're working for Cisco, Dell, or, you know, Oracle or anyone else, they have a job to do for which they get paid, and they're doing this sponsored by their company and paid for by their company, but it's additional work for most of these individuals. You know, and some of it is quite onerous because they're trying to work to deadlines. So it's quite an interesting mix of how this has all come around and the way it actually gets driven and the way it's been pretty successful over the last few years.
It's got much, much better.
Good, thank you. Pleased to hear it. Okay, thanks very much, guys.
Thank you.
Cheers, Bob.